So this is the second part to this that we're building up, the second lesson, but we're going to recap a few things. So here's our circle again. We have our radius is our line that goes from our center to the edge. Our diameter is our line that goes all the way across. Last time we talked about the circumference, which is all the way around the outside. Now, there's two other terms that we're going to be using a lot in the next little while, and that is if I've got a little section of the outside of the circle. So, for example, I've got this section here, just the bit from here down to here. That is called an arc. So that's not the whole of the outside of the circle, it's just one little section of it. The second term we're going to use a lot of is this wedge-shaped bit here. So they're kind of like a pizza slice out of our circle is called a sector. And so for the next section of lessons, what we're going to be talking about is the arc length, which is how long this section here is. So can we find that? And we'll be able to find the area of a sector. So this one's going to be about arc length. And the third lesson for this week is going to be about the area of sectors. So let's have a look at doing that. Now, this is a sort of example that we might have. We might be asked to find the length of the arc. Apologies, that's gone off the top of the camera. So find the length of the arc, and occasionally that might be labelled, so you might have, say, letters A and B, so you'd refer to that as arc AB. Now, we don't as yet have any way to do that. We are going to hopefully learn a little formula that will do that for us, though. So here is a key formula that we need. So arc length is equal to, now if we just had a normal circle, well, this is part of the circumference of the circle. So the circumference of the circle is pi times d. But we don't have the whole circumference of the circle, we've only got a little bit of it. How much have we got of it? Well, we have a fraction of it, which is whatever the angle we are given out of a whole circle. What's the angle in a whole circle? The angle in a whole circle is 360. So this formula here is a key formula. It tells us how to find the arc length if we know the angle that we're given and we know the diameter or the radius of our circle. So let's use that. So using that, we get 50 over 360 times pi. And remember, it's diameter going in here, so this has got a radius of 9. So it's got a diameter which is double that, so 18. Working that out, we get 7.85, 3981, 63, etc. And then we can create our rounded answer, which is 7.85. And that's a length, it's an arc length, so it'll just have units of being centimeters. Okay, so there is a nice example of using our arc length formula to find ourselves an answer. We are going to do a second sector here, so that is going to be this one. So if we have 70 degrees in there and our radius this time is going to be 10 centimeters. So if we want to find the arc length, we want to write down our formula, which is angle over 360 times pi times d. Putting our numbers in, that is 70 over 360 times pi times 10. Putting that into a calculator, Now I spotted I made a mistake here, and actually it's one to watch out for. It shouldn't have been 10 here. We should have doubled that radius. So we should have had 20 because we want to put the diameter in, not the radius. So putting that into our calculator gives us 12.217304764, and then our rounded answer is 12.22, and again, centimeters is our unit. So be really careful with that detail. Apologies for making the mistake, but hopefully you can see that it's an easy one to make, but quickly correct it if you spot it. Now, last example we're going to do in this one, I'm going to do an arc length of this. Now, there's one thing to be careful of here. I want the arc length, which is this bit here, but I'm given the angle of this bit. So very first thing we need to do is figure out this angle here. Well, whole circle is 360. So let's do 360, take away the 40. That leaves us with 320 degrees. And now we can start finding this arc length because we've now got the angle that we need for our formula. So arc length equals angle over 360 times pi times d. So always write your formula down before we start. And then we're going to work our way through with that formula. So we're using that angle that we worked out, which was 320 over 360 times pi. Diameter, well, remember radius is 12, so the diameter is double that, which is 24. Put that in a calculator. Doing that gives us 67.02064, etc., etc. And so our rounded answer is 67.02 centimeters. So there's 3 examples which hopefully give you a really good idea what you're doing. What I would like you to do is, as a bit of a your turn, have a go at this one, and in the next video I'm going to run through this one and show you the answer.